Hi everyone, this is Mrs. Lehman from Math with Mrs. Lehman, and I'm here with my third period class again, and they have a special surprise for you.
Insert intro.
They came up with that all on their own. Very nice. All right, hope you enjoyed the intro. So today what we're going to do is continue learning about drawing the coordinate plane and plotting points on the coordinate plane from lesson 17 of the grade 6 New York State module. So really our objective today is to adjust the scale of the x and the y axes and to make sure that we can accommodate all of the points we've been given. So we've already had a brief discussion about reviewing yesterday's lesson and how the x and the y axis can have different scales because you're dealing with different coordinates there. So you want to look at all your x's first and then come up with the scale that will accommodate all of those numbers, and then look at your y coordinates separately and figure out a scale for those depending on how much space you have on your coordinate plane. All right, so we are going to pick up on page 72 of our module book, and that's example 3, drawing the coordinate plane using a decreased number scale for one axis. So up until now, we've done a 1-to-1 scale, and we've done one where we had to count by 5s to accommodate some numbers. So in this case, it says that we have 5 different points here to plot. So who can go through and read me all of the x coordinates? All right, go ahead, Ava.
0.1, 0.5, 0.7, negative 0.7, negative 0.4, and 0.8.
Very good. So we're dealing with a lot of tenths here, right? So we've got 5 tenths, negative 7 tenths, all of these things. What do you think we could count by to make sure we can get to, our highest absolute value here, which is 8 tenths? What should we count by? Peyton?
Tenths.
Tenths, yeah, it makes sense, right? So let's go ahead and do that. Now we had a nice discussion also about how we don't necessarily need to label every line, but when we refer to scale, it means what is each jump worth. So I'm not going to label every jump, I'm going to label every other jump. So if each one is worth 1 tenth, I would be labeling, for example, 2 tenths, 4 tenths, 6 tenths, 8 tenths, and then this would be 1. And then I would do the same thing on the negative side of this. So negative 2 tenths, negative 4 tenths, negative 6 tenths, negative 8 tenths, and negative 1. All right, any questions on that? Pretty easy. All right, so we're all done with that. Now we're going to move on to looking at our y coordinates. So can someone run through the y coordinates for me? Calvin?
4, 7, negative 5, 3, 1.
Very good. So what do you guys think a good scale would be if our, what's our highest absolute value? 7, yeah. 7 is our furthest one from 0, right? So what could we count by? You want to count by ones? Everyone's, yeah. They're saying 1 to me in sign language here. So we're going to count by ones. Again, we don't have to label every one, so I'm going to label every other one. So, oops, I want to go do these on the left. So 2, 4, 6, 8, and 10 up here. And down here we're going to have negative 2, negative 4, negative 6, negative 8, negative 10. Alrighty, so I'm going to pause this video because our next step is going to be to name these points. And again, we kind of joked about this yesterday. We're not going to call them Bill or Bob or anything like that. We're just going to call them capital letters here. So we're going to give them a name so that way we can label them with the name instead of the ordered pair. We'll come back in a second when we have these all plotted. Thanks. All right, so this is what your graph should look like. We have points A, B, and E in quadrant 1. We have point D in quadrant 2. We have point C in quadrant 3. And there are no points in quadrant 4. Can someone quickly tell me, just since we're talking about this, what quadrant is this point? We'll call it point F. What quadrant is that in? Lola? I'll come back to you for a different question. Kaylin?
It's on the y-axis.
It's on the y-axis. Is it in a quadrant?
No.
No, classic trick question. All right, so be warned for that. If it's on an axis, that's what threw Lola, right? Yeah. If it's on an axis, you know, a question might say, is point F in quadrant 1, in quadrant 2, quadrants 1 and 2, or none of the above, or something like that? And the correct answer would be none of the above, because a lot of kids are like, oh, it's in quadrants 1 and 2. No, it's not in a quadrant if it's on an axis, right? Ooh, let's really get fancy here. I'm going to erase this. Who can tell me, all right, what were the coordinates of point D? So it's -4/10 and 3. All right, who can tell me what the coordinates of the reflection of point D is in the y-axis? We want to reflect point D in the y-axis. Who can give me the new coordinates? Amaya.
4/10 and 3.
Very good. Nice job. 4/10 and 3. So instead of going to the left, it would go to the right, and it would be right here. Nice job, Amaya. Does someone else want to try one?
Yeah.
This is something you need to know how to do. All right, let's do a reflection of point C. What are the coordinates of point C? Oops. Hold on. Please hold. -7/10. -5. Okay. All right. Who can tell me the reflection of point C in the x-axis? You want to reflect it in the x-axis. Stone, what do you think?
-7/5.
-7/10.
5.
5. Very good. Nice job. Someone else want to try one? All right. Let's do a reflection of point E right here in the y-axis. A reflection of point E in the y-axis. So we're going to use the y as the mirror. Campbell, what do you think?
-1.
Huh?
-1.
Is that +8/10, +1?
Mm-hmm.
So what coordinates, what would you say for the reflection in the y-axis?
I don't know.
So again, we want to think of the y-axis as our mirror, okay? So which coordinate is going to change, your x or your y? No, your x. All right, take 5. All right, so you're changing your x coordinate, right, to its opposite. So instead of +8/10, we're going to go to -8/10. It's still going to be 1 up from the bottom, right? So you're going to have 1 as your y coordinate. Okay, he's like, oh, I regret this already. All right, let's try another one, okay? All right, I'm going to make up a different point here. So let's change where I put point F. Let's say point F was at, please don't say that, +3/10, -2. So +3/10, -2, that's in quadrant 4. And I need that to be reflected in the y-axis. So we're using the y-axis as the mirror. So what would the new coordinates be with a reflection in the y-axis, Lola?
-3 times -2.
Very good. You guys getting the hang of this, you think? Possibly. All right, well, we are going to, unfortunately, have to move on. Let's see. Yeah, so we're good there. Let's go to the next one where we have a situation where Mrs. Lehman didn't erase. All right, it's all fixed now. So anyway, on this example, we need to draw and label the coordinate plane. So you guys already drew the coordinate plane. Make sure you have arrows on the end of the axes and that you have them labeled. We're also going to name these points. So I'm going to call this one A, this one B, C, D, E, and F. And we now need to look at setting up our scales for our scale for our x-axis. So we've got -14, -4, 6, 14, 0, and -8. So what are you guys thinking? Are we going to have enough room if we count by ones? No. No, we'd run out of room, right? So what could we use where we wouldn't run out of room, but we'd still be making good use of our space? Peyton?
Twos.
Twos, yeah. Does everyone see where counting by twos would be a good thing? Yes. We get up to 20, right, on each side. Yep. Because each jump's going to be worth 2. Now, you can see where that's like a lot of writing on there. Okay, so even though I'm counting each jump is worth 2, you may only see this, for example. Okay, each jump is still worth 2. It's just I'm not labeling every line anymore. So -4, -8, -12, -16, and -20. All right, does everyone have theirs all labeled? They're working on it. Make sure you have negatives on your negative side. I'm going to put 0 here in the middle. Okay. After you're done with that, what's our next step? What do we need to look at next? Our what? Not our y. Well, our y scale, right? So we're going to look at our y coordinates. All right? So that's what Zulima was expressing. So, Zulima, do you want to read through the numbers we have for y coordinates? She's adamantly shaking her head no. Does someone want to help Zulima out here? Camera shy? Even though there's no real camera here.
Except the y ones, right?
The y coordinates, yes. Thanks, Kel.
Oh, 2, -5/10, -3 5/10, 2 5/10, 3 5/10, -4.
Beautiful. All right, so what's the highest absolute value we have to get to? Look through those numbers. There's a higher one than that. Cadence?
3 5/10.
Higher. There's a higher one.
Oh, what's here?
Campbell?
-4.
-4 would have an absolute value of 4, right? So we've got to get our scale set up so that we can easily get up to 4, but we don't want to like count by ones and only use, you know, that section of the coordinate plane. There's a better way. What could we use? Lola, what do you think?
5/10.
5/10, very good. So if we count by 5/10, we'll be able to get up to what is our highest number here? 5, very good, because we have 10 jumps. So 10 divided by 2 would be 5. All right, so what we're going to do here is I'm going to label every other one. So this would be 1, this would be 2, 3, 4, and 5. And again, each jump is worth 1/2 or 5/10, even though we're only labeling the whole numbers here. All right, so then the next step is to plot the points. So I'm going to pause this while we get that done. Okay, so we have all of the points plotted here. We've discussed that point D is in quadrant 1. Where's point A?
Quadrant 2.
What points are in quadrant 4?
C.
Just C. What's in quadrant 3?
B and F.
Where is point E?
On the Y.
On the Y. It's not in a quadrant, it's on the Y axis, right? So what coordinate was 0 for point E? Ava? The x coordinate is 0. If the x coordinate is 0, that means it's going to be on the y axis. All right, any questions about this? What questions do you have? Anything? Kayla, no? Nothing? All right, guys, so I just want to emphasize to take your time when setting these up. Consider your room, consider the coordinates that you have to work with, and when you're plotting points, when you have an altered scale, it takes an extra level of concentration. So please take your time. Anyway, thank you for watching Math with Mrs. Lehman. I hope you had a wonderful day today, and have a great day.